Good morning to everyone. In today's video, we are going to our next topic, that is minimum attenuation. So already in our previous videos, we come across with the derivation of attenuation constant and phase constants. Okay. So here from the propagation constant, we find out what is the attenuation constant and phase constant here. So from this attenuation constant, we are supposed to find out what will be the minimum attenuation. Okay. So I just taken the formula of I'm just taking the formula of attenuation from here. Okay. So from attenuation constant, I suppose to find out what will be the minimum value. So either to get minimum or maximum value, we supposed to derive that value and equate to 0 to find out the roots where we get the minimum and maximum. So we derive this your function. Okay, we derive this function alpha to the variables. Here we are having the variables of r, g, L and C. Among these, L and C will be depends upon your frequencies. L and C will be depends upon your frequencies. Those we can consider it as a variable quantity. So you may consider d alpha divided by dl equals to 0 or d alpha divided by dc equals to 0. Here I am considering inductor as my variable quantity. So after getting the derivation, we have to equal that one to the 0. So first of all, I am going to derive the your function. So d alpha by dl. Later I equate to 0. So here alpha value will be square root of some it's an expression. Okay, square root of an expression. So for ease of my understanding, I just written the derivative of square root of x. Okay, square root of x. So the square root of the derivative of square root of x is nothing but 1 by 2 root x dx by dl. So if you take this 1 by 2 root x, if it equals to 0, this value is also equals to 0. You simply can find out dx by dl equals to 0. Sorry. So here I'm just even no need to write the value. For ease of understanding, I'm just written 1 by 2 root x here. So this is alpha value. So 1 by 2 root over your alpha value, nothing but your x value. I'm just written d by dl of your rest of the alpha value. So whatever the inside the square root of term is there, I just written that. Okay. So you may forget about this term. So directly you can go for the this term. So we have to do the derivative of each and every individual term. So this 1 by 2 is my constant, so I just bring it out. So d by dl of this term, and again here also 1 by 2 is a constant, I just bring out, and d by dl of rest of the element. So now 1 by 2, this is independent of L, that's why we can consider it as a constant. So derivative of constant will be equals to 0 minus, here L will be in first order term, so omega square c, and here again it is in the combination of d by dl of root over x. So d by dl of root over x will be nothing but 1 by 2 root over x dx by dl. Okay, so 1 by, already 1 by 2 is there, again 1 by 2 into root over x, your constant, and individual term derivative. Okay, so here again it will be r square plus omega square l square into g square plus omega square c square. So derivative of internal, this r square will be constant 0 and L square will be 2L and G square will be independent of term, because we have the only constant of this one. So you may consider it as an UV format, or you can directly go. Okay, so derivative of this one itself we considered. So the rest of the thing is common. So the final expression will be minus omega square c divided by 2 plus g square plus omega square c square into 2 omega square L divided by 4 into root over entire term. So equals to 0. So now I take this term to right hand side. So whatever the common terms are square omega square cancel over, and 4 and 2 denominator terms also cancel over. Again here it is 2. So the rest over terms will be, so this 2 will be also getting cancelled. So now c divided by L. So here I have the square root on left hand side. So squaring on both sides. When I perform the squaring on both sides, it will be g square plus omega square c square divided by r square plus omega square L square equals to c square L square. Okay, c square L square. Cross multiply. After getting cross multiplication, this term, I mean omega square on both sides will be same. So cancel over to each other. So take the square on common. So GL square equals to RC whole square. So squaring on both sides will be cancelled over. So the rest of the element is GL equals to RC. So or we can write it as, by cross multiplying, L divided by C equals to R by G. So this is the condition for minimum attenuation. Okay, thank you.